So thank you everyone, first of all, for joining us on a Sunday morning for this AI bootcamp. I'm all excited to talk to you all about cognitive services and making it work with and hosting cognitive services on containers managed through Kubernetes. So we all know, before we get started, I'll just introduce myself. I'm Ritesh Modi. I'm a ex-Microsoft tech evangelist. I'm currently a Microsoft regional director, which is like an honorary title. I'm also the Microsoft India lead for Microsoft certified trainers. Uh, Apart from that, I've written a few books. I think 8 in total. And one of the couple of books are very relevant on cognitive services. Like I've written a book on bots, which is conversational artificial intelligence. And at the same time, I've written a book, couple of versions for Azure Architecture as well. So that's a small introduction for myself. And as I told you before, I'm going to cover cognitive services along with Kubernetes. And we know cognitive services is a big topic, and is a big topic from an artificial intelligence perspective. And we know Kubernetes is a big topic from hosting, or basically how we should be using infrastructure to host our applications and different assemblies and code and runtimes on top of it. So mixing both of them makes quite a few sense, because we want to create intelligent applications, and when we create intelligent applications, obviously it needs a place to store, it needs to be hosted. And to host it, we have quite a few options. Primarily, we have an option for storing, for hosting our code on, for example, a plain and vanilla virtual machines. So we can create virtual machines on the cloud, and we can host our application on top of it, which is internally using cognitive services. And at the same time, if we are not interested in hosting our applications on virtual machines, we can host it on app services on Azure. For example, which is the platform as a service, whereas virtual machine was infrastructure as a service. So we can host it in platform as a service, where we create an instance of an app service plan and an app service, and we go into our application on top of it. There are definitely advantages of using platform as a service, where we don't have to manage the underlying infrastructure. We don't have to manage and patch the virtual machines that we create in case of IaaS. But at the same time, there are maybe better alternatives, and a couple of them one being serverless, and the other being using containers and containers. So let me talk a bit about serverless and containers as well. So a step forward from an app service or a platform as a service would be serverless, which means now that if you deploy your code on a serverless, like for example Azure Functions, you don't even need to manage even the platform. It's a pay as you go, which means if you do not consume anything on your serverless platform, then you don't even pay anything. Whereas when you create an app services, you start paying the time you create an app service, whether there's a consumption or not. So definitely cost optimization is big with regard to serverless. More of it enables you to take away event management of the platform. So that's again a big plus for serverless. The third important point to remember about serverless is that it is infinite. It has infinite scalability and availability associated with it, which is also not, the scalability is there within app services, but it's not infinite. You need to make sure that you configure auto scaling in terms of some metrics or some parameters. But in case of serverless, if whether it's one user or a million users, it just doesn't matter. As a deployer, as an owner of the serverless, the Azure will, for example, or the cloud will, for example, make sure that every request is being served with an optimal performance that's needed by the application. So that's a big advantage for serverless. But now there's a fourth option, as I was talking about, was containers. Now containers are a hosting platform, and Docker is one of the primary open source. I think somebody's speaking, so I think we can have a Q&A towards the end of it. So if you can mute yourself, that would be great. So containers are big, and Docker is one of the main proponents for containers within our ecosystem. But what are containers? Containers are primarily, so I'll just skip a bit of slides and come back to cognitive services. So as I said, Docker is one of the main players within the container area, and containers are primarily basically when we want to create an isolated environment and we want to host our applications on top of it. So we just go and create containers instead of virtual machines. So basically, containers are contains all the good parts of virtual machine, which means it gives you complete isolation, it gives you complete security boundary, it gives you complete isolated environment like your own namespaces, your own IP address, your own registry, your own file system, and your everything is with a new host name and things like that. At the same time, you can create a container on the fly within less than few seconds rather than taking few minutes. So it helps you enable DevOps because you can create hundreds of containers simultaneously at the same time, which within few seconds rather than minutes, which typically is missing on a virtual machine. You still need some time, 5 to 10 minutes, to create a virtual machine. And so if you really want faster deployment, easier deployment, and predictable deployment, containers are a way to go forward. One of the limitations of containers is that if you create a container and deploy on a virtual machine, then typically you need something to manage those containers. And, and to manage those containers, typically you need an orchestrator, because if a container goes down, for example, the virtual machine reboots, and all your containers within that also goes down, then there should be somebody to look at it and say, yes, we want to start those containers back. And so you typically need an orchestrator, not only for high availability, but also for scalability, and also to manage the overall life cycle of those containers. So you can have multiple virtual machines and you want to, put those containers on different virtual machines and make them work together, make them recognize each other on the network, make them talk to each other on the network, and work as a complete solution and an application on top of it. So your application might be decomposed into multiple containers, having each layer and tier might be having multiple instances. So for example, your front end might have 3 containers, your application layer might have 4 containers, and your backend system might have just 1 or 2 containers. So depending on the layer, you might scale up and scale out depending on how much resources you want to associate with containers. So it's a great technology, and that's the way to move forward. We all know it. And so today's topic, as I said, is to first of all create some cognitive services and then deploy them on containers and then manage those containers using Kubernetes. So the normal process typically that we follow when working with containers is that we need to create a Docker file. And what's a Docker file? So we know to create, for example, a virtual machine, the place we need to start with is to identify an image. So the first thing we figure out, it's a Win 2016 with containers image, or a Windows 2019 container image, or it's just Windows 2012. It could be Windows 10 or an Ubuntu machine and things like that. So we need to identify an image before we can get started to create a virtual machine. Similarly, in the containers also, we need an image to get started with. And there are multiple types of images. There are Linux images, there are Windows images, there are different versions of Windows and different SKUs of Windows, and similarly for Linux as well. So we need to get started with an image, and we can quickly create a container out of that image. So which is good, which is great. But if we want to customize, if we want to create a image which contains our application on top of it, then we need to write a Docker file. A Docker file is simply a text file, basically. And a text file means we write commands in that text file and say, this is our image, this is our base image. And these are the steps, these are the commands we need to execute to ensure that the image contains our application on top of it. So I'll just quickly show you how to create maybe a Docker file and show what it looks like. And once we have a Docker file, we need to convert that Docker file into a Docker image. So when we build the Docker file, we get an image. And that image is something which contains our entire application. So in our case, our image will contain the entire an application which is consuming cognitive services. And eventually, when we run that image, when we use that image to create a container, we get a Docker container, and that has an instance of our application running. So that is what I'm going to show you immediately. So, and how do we then, once we have a containers, then how do we manage those containers? That's where the Kubernetes comes into picture. So quickly, let me go back and talk about the different cognitive services we have, and then get back to the demos and show you how the entire thing works together. So cognitive services are primarily RESTful APIs provided by Microsoft. So they are, at the end of the day, HTTP requests, and you get a response back. but there are a host and a ton of such REST APIs. So it's not one or two, it's maybe around more than 50 or 100 of them. And they have been basically categorized into different categories like vision, speech, language, knowledge, shows, as you can see on the screen. And each of these categories further has multiple different REST APIs and the different kind of capabilities. For example, we have something called computer vision, which helps us detect objects within an image, for example, which helps us do OCR, which means if I send a piece of image, it can figure out the text within those images and give it back to me. Similarly, for emotions, it can, if you send some pictures which contains images of people either laughing or crying or whatever they're doing, it can identify the emotions and provide it back to you. Similarly, for the face and videos, and a ton of it, you can see it's just a representation I'm showing you. There are much more than this. And there are more cognitive services keeps on coming. But at the end of the day, when I say it's a REST API, what does it mean? What's happening behind the scenes? So I'll just take a couple of minutes to explain that. So what happens typically is if you want to create intelligent applications, so typically you create an application and it has some functionality. And if you want to introduce intelligence into it, you need to resort to something called artificial intelligence, machine learning. There are it comes with multiple shapes and sizes. I could be doing a simple usage of an algorithm, like for example, classification or regression. And once I identify the algorithm or the problem I'm trying to solve, I typically take a business model. I create a model out of it. So algorithm is something which needs a model. What is a model? Model is something, if you want to relate to a databases, it's something like a schema of a database. So I know what the business problem I'm trying to solve, and I have a model which is nothing but the kind of schema that I'm going to play around with. But schema is no good, and a model that is a model and an algorithm is no good if you don't have data into it. And that's why you try to feed data into training data and test data. What is your training data? Training data is something which you use which you inject within your model and use the algorithm to come up with a solution or a trained model. And then you use your test data on the trained model to see how good or bad your model is. And if it is not meeting your expectations, then you either change your data, bring more data, either your data is skewed earlier, so you try to normalize your data, or what you do is change your model itself, because the model might have features, might not have features that is needed, or might have features which are irrelevant. So you try to do these things, and that's what it's all about. Machine learning, it's a continuous process, and you do that. But this is quite a lot of activity to do for a typical startup or an application who is trying to build an intelligent application. And Microsoft realized this, that no, everybody does not have that kind of data that they need. Everybody does not have that compute power and the storage power that they need to write neural networks, deep learning, and do all of those steps like modeling and getting data and crunch the data and try to get insights out of it, build a model out of it. So they build this cognitive services, and those cognitive services means the hard work of doing all the AI ML products and generation of models and all have been taken care of by Microsoft. What you need to do is just consume those services, bring your own sample data and see whether it works for you. And if it works for you, then you can convert those services, REST APIs, into your model and then use it within your application. So that's the way you create your application, which is intelligent in nature. So you call an API which knows your model. So you send the parameters to it and it returns back the value that you can use it within your application to do the necessary processing. But one thing to remember with regard to cognitive services is that it's always a probability, which means the return value that you get is a probability. It might be 50%, 60%, 70%, depending on how you train your model. And it might be correct, it might be wrong. So you need to take a calculative decision if 80% is good for your application returned by cognitive services or not. If 80% is good, then you take a particular action. If 80% is not good, then you take another alternative set of actions. So depending on what business domain you are in, what application you're building, you need to judge the probability and take action. And that's also called an open loop and a closed loop in terms of artificial intelligence jargon. So this is typically an open loop, and where you need to take a decision about what needs to be done with regard to this probabilities. Being said that, I think let's move forward and show you how these things work. better. So what I have is, if I go to my Azure portal, I already created a Kubernetes service, AKS, which we call it in Azure. So it's called AKS Cognitive. And I'll take you through what it looks like. And I've also created a resource group called Cognitive. And within this Cognitive service, I have created, a cognitive service called Vision API, right? So it's called Vision API, and there's some keys, and you can see. And at the end of the day, it's primarily an API call. So you can see when we go to the overview, it's an endpoint is there. So I need to use this endpoint along with the key that I just showed you to invoke a response from the cognitive services. So once this is created, once the AKS is created, I have created a solution. I'll quickly show what it looks like. So this custom vision, so this is a vision API I'm using, which means I will be submitting some images to it, and it will do some OCR for me, for example. So for one example could be that, in the toll booth, like how the FASTag is working. When the toll booth, takes a picture of the car that's passing, and it reads the number plate, for example, it reads the number plate. It also has a FASTag, so you can read that FASTag itself instead of number plate. But you can also read the number plate as well. And it's an image which will get transferred to your application, like this, for example, which we'll be hosting. This is an ASP.NET MVC application. And when this image comes over here, you can read that image and eventually get data out of it. That what kind of image is there, you can get the entire data out of it. So if we have to take an example, if I try to run this particular service, say for example, if I run the service locally on my machine, then if I submit an image to it, it will tell me what the data is within that image. So let's go and try to run this and see. So this is plain and simple vanilla ASP.NET. So I'll go to the code. So this is running on localhost 5000. So if I go back to my window and say localhost 5000, let's see what the body is. So you see I'm supplying an image. So if I go and see what this image looks like, let's go and see this, what this image looks like. So see there's a car number over here, like it says in HR 26DK8337. Now if I go back to my application I just showed you, in this application, what I'm doing is I am using the URL that I showed you of the Vision API, and I'm using that token. And then I need to invoke this API. So I need to create an instance of HTTP client, and I pass on that HTTP client, I pass on the URL, and once the URL gets created, eventually what I do is I pass on the request of the value. The value is primarily the parameter which I'm getting here, and it contains nothing but the URL of my image. So I pass on that image URL. I pass that image URL. Over here you can see that I'm creating a GET request. Once I do a GET request, I get a response back. Once I get the response back over here, I try to deserialize it because the request comes in JSON format. And so I deserialize the JSON format and try to loop through it and see what text are there within it. So this typically is doing OCR. You can see that I have a Vision API and it says OCR over here. So this is doing OCR for me. And now if I try to go and submit this request over here, it gives me exactly the text that's there in the image. So this is creating an intelligent application. So if you need to write your own OCR, it might take a few weeks, the logic for that, or maybe months, who knows, depending on how robust you want an application. So this is something which is out of the box. So OCR is there out of the box in terms of custom Vision APIs. You just need to go and use it. Now I already have this application built. Now how do I host it? To host this application, as I said, we will convert this into Docker containers. And once we convert into Docker containers, we'll manage using Kubernetes. So one big thing we can do is we have something called Docker. And once we run this, if we go to a command prompt and say Docker images, a new image should be there which says Web Application 7. You can see that. So as soon as you build it, a Docker 7 image is there. It's got built. You can see it's just 1 second ago. And as soon as you build it, you can use it to create a container out of it, because this is an image. As I said, image is used to create a container. So this is just an image. As you can see, I typed Docker images. So now I want to host this in AKS. As you saw before, I have something called AKS over here. I want to host it over here. So AKS is nothing but an orchestrator, and let me show you the architecture for that. So AKS is an orchestrator which manages the lifecycle of containers, and the architecture for that is primarily here. So as you can see here, that when we create a Kubernetes cluster, we call it cluster. We have two kinds of nodes: a master node and worker nodes. So what you see on the top is the master node, and what you see a couple of nodes below are the worker nodes. So master node contains all the administrative components like API server, controller manager, scheduler, etcd, etc. Plus the worker node contains all the pods. Pods are nothing but group of containers together. So the lowest unit that a Kubernetes manages is a pod, and pods are nothing but collection of containers. So eventually you can see that Kubernetes manages containers. And one of the pattern that we typically use in Kubernetes is that there should be one container per pod. You can have more than one container in a pod, but those containers should be, pods which help the main pod provide more functionality to it, like ancillary pods. There should not be two different functionalities in the same pod. So pods, you can think of it one-to-one relationship with containers, then that's better in terms of Kubernetes. So we have something called kubelets and advisors and kubeproxy, which are kubelet is basically an agent that talks to the API server and gets all the information and takes command from it. Whereas kubeproxy helps in exposing our pods to the external world as well as to the internal world, so that we can consume those services that's within those containers. And cAdvisor helps in monitoring. It helps in providing audit logs and things like that, so that we can actually know the health of the pods and what's happening with pods and containers within them. So this is an architecture for Kubernetes. And how do we manage Kubernetes? We manage Kubernetes using something called a tool called kubectl. So we need to download this tool, and if we type kubectl, for example, and we can manage our Kubernetes directly from here. So if I want to see how many nodes are working in my Kubernetes, so if I just type a simple command like kubectl get nodes, it will tell me I have 2 worker nodes running. You see, I have 2 worker nodes running. And if I want to know the details about these nodes, and I can say kubectl describe and take the name of one of the nodes. So if I take the name of one of the nodes, I have to provide describe node. And it tells me a lot of information about those nodes. Like, for example, it's a Linux-based machine, it's a Ubuntu 16 LTS, what's the kernel version, and what's running on those nodes. So it's telling me these are the things that's right. So I can do a lot of things with kubectl. That's the management tool for me for working with Kubernetes. So now I want to host my application, which you just saw here, as containers within my Kubernetes. So what I can do is what I will do is typically I'll come back and I need to push my image, the image that you just saw before, this image, I need to push this image to a container repository. What a container repository? Container repository are a repository where we host our images so that we can share it with others. Like, you create your image once on a dev environment, and then you put it into a repo, and once it's in the repo, then your test environment can pull that image from the repo. Once you're done with the tests, you can do system integration test environment you can pull that same image in, And then maybe when you're doing UAT, you can pull the same image. When you're going to production, you can pull the same image. So you need a repo where you can store those images. Docker Hub is a great place to store images, whereas Azure also provides a repo called Azure Container Registry where you can host your images. So I have already created an Azure Container Registry. I will just show you quickly. I have a container registry within a resource group called ACR Part 1. And I have a repo here called ACR AKS Part 1. So here I have my repo where I've already pushed Web Application 7 in my repo over here. So you would see that I have quite a few images over here, and one of them being Web Application 7, you see. So how do you typically push it? I'll just show you the steps to do that as well. So typically what you do is you need to log in. You need to, give me a moment. So what you need to do is typically you would go and first thing you would do is to build your Web Application 7. So I'm calling it my classifier here. Once you do the build, it will generate an image. But the image is available only on a local machine. It's not available on your repo. So to put that machine, let me take an example of Web Application 7 itself if I have it. Yeah, it's here. So once you have Web Application 7 built, you need to tag it because you want to push to a repo. So I need to make sure that it is using my ACR AKS Part 1. If you remember, that was my repo. So I am renaming my Web Application 7 to ACR AKS Part 1 ACR. Once the rename happens, then I can log into my repo. If I go back to my repo, I can show you these credentials. So if you go here, you will notice that my repo is called ACR AKS Part 1 Azure CR.io, which maps to what I've typed here. So I'm logging to this server, and what is my username? So you can see that the username is ACR AKS Part 1, and the password is here. So I'm using the same credentials actually to log into my ACR. I'm using the same credentials to log into my ACR. Once I log in, I just need to push that new image. That's all. Once I push my image, it will be available over here. So now it's available in my repo, and now I can use in my Kubernetes. Now Kubernetes can reach out to this particular image, download it, and create a container for me. So, and to do that, I will create a file called a YAML file, which will contain the instructions that I am going to provide to Kubernetes to install that, create a container for that particular image. So how does it look like? So if I go and save my YAML file, let me open it for you. So you see what I'm doing? I'm doing a deployment now. I already have a Docker file. I'm a Docker file. So let me show you the Docker file for this particular application. So if I stop it, so I had a Docker file which I use for building an image, and I push that image to a repo. And now once it's in the repo, I already have created a Kubernetes cluster. I will come and create a YAML file which contains instructions to tell Kubernetes how to create a container and how to expose that container to the outside world. So I create a deployment first. And within the deployment, I am telling that you host Web Application 7 as an image. So create a container which has Web Application 7 as your image. Expose that application on port 80 so that we can consume it. So let me rename this. Let me rename it and make it Web App Cognitive. And I'm going to reuse this everywhere so that I can use it immediately. So I'm not even getting into the details of Kubernetes over here, which we can do it maybe in some subsequent session. But understand that what I'm doing here is that two kind of objects here. One is called service, one is called deployment. The deployment is what actually creates my pods on Kubernetes, and service is what exposes those pods to the outside world using a load balancer. So I'll save this file, come back to my Kubernetes environment, and I'm going to say kubectl apply, and I'm going to provide the path of my YAML file. So you see it says that web app cognitive created and the service is also created. Both the deployments and the service have been created. So if I want to check the pods that I have now on my system, you would see that the web app cognitive is running over here. And how do I access this web app cognitive pod? I need to use a service. So if I say get service, there is a web app cognitive over here, and this is available on the port 52137 on the IP address this. So I'm going to copy this, come back to my environment. I'm going to put this IP address now instead of my local host. I'm going to send it to it. And you see I get the response back. Now if I take another image, for example, let me go and find out one more image. I go to images.google.com and say find car number plates. Now let me take this one, for example. So I'll copy this, the image URL, come back to my environment. And by the way, this is online. You can also use it. If you want, you can also hit this URL. You can hit this URL, make a post request if you have Postman, and provide an image to it. This is right now available globally, and it took me just less than 10 minutes to get this stuff. So you give me something, but this is obviously that it's trying to train. So let me take this image. It's not an image of what. Let's take one more image. So my internet is not all that great today, so give me a moment. So meanwhile, let me see if there are any questions. Can't even open this site over here. I hope you get the picture of what I'm trying to do. So we can have open up the question answer session right now. So if you have anything you can want to ask, go ahead, please.
Folks, if you have any question, you can just unmute yourself and ask Ritesh, or you can type in the message box also.
Hi Ritesh, Suresh here. I need to know how you are generating the YAML file from your application. Uh,
So YAML file is not generated. I have to write it. So you can't generate the YAML file. You have to write it.
okay, that template we need to write.
You need to write that template. That's correct.
Okay. See, if you don't mind, one more question is the container contains multi collection of parts, right? Nodes. Nodes
Can you
contain
repeat?
difference. That difference I need to know. I am not getting that point. What is
Could you repeat
con-
that?
see in
What
a
is container?
container how? Yeah, no. In a container, see, collection of container contains nodes, right? A node, the difference
No,
I
no.
not understanding.
So okay, I'll explain that again. So this is the relationship. You see, nodes are nothing but virtual machines. Nodes are virtual machines, and virtual machine contains pods, and pods contain containers. So you have a node, and
Okay.
that node have multiple pods. So if I go
Mm-hmm.
and I can show you how it looks like. So for example, if I come and see how many nodes I have two nodes, right? Now within one of the
Yeah.
nodes, if I say CTL get pod. So for example, we created this pod. So what is this pod? So if I go within this pod, I say kubectl describe pod and I give the pod I name, then you would see that this pod is actually hosted on this particular node and it contains containers, you see. And the name of the container is it has just one container and this container details are over here. So what is the image for the container? Was the image that we created. And what is the condition? It is currently initialized, it's ready, and does it has any volume, and what is the current messages events that we have for it. So the relationship between all of these things is a node is there, which is your VM, which hosts pods, and pods host containers. I hope that is clear now.
Yeah.
Yeah.
Got it. Got it. Got it.
So now the other thing I wanted to show you, since this is working, the other thing I wanted to show you was how many pods do we have right now? We have one pod for our application. Let's say get pods. We have one pod over here. So now I see a lot of demand for my application. Means a lot of people are coming in and joining. I want to scale up. So I can scale up immediately by saying kubectl scale deployment. I can say web app cognitive, and I can say number of replicas is equal to 3. Now if I go and check the number of pods I have 3 pods all of a sudden. It took me less than a second to create new pods. So that's the beauty of containers and Kubernetes, that now my application has a lot of demand. I can just go ahead and increase the number of pods as I feel like. But this was called manual scaling. If I want to do auto scaling, I can say kubectl auto scale deployment web app cognitive I can say CPU. I can say CPU percent. And I'll just give a figure of, say, for example, 1, so that immediately it'll scale up. So max is 5 and min is 1, which means I can go max to 5 containers, 5 pods, and I can go minimum 1 pod. So I've given CPU percent as 1, which means even if 1% crosses the CPU utilization, it will auto scale to 5. So right now, if you know I have 3 pods running, I run this. So it says max not set. So let's give this, which is fine. And now you can see that auto scaled. Now if I send a request to it, for example like this, now and go and check the number of pods. There's still 3. So if I keep on sending some requests to it, they will auto scale automatically whenever. So let me reduce the number of scale first. Let me reduce to make it 1. And now since I have 1 only, you see it became 1 now. And now if I try to increase some, I want to put some request onto it, come back here. Yeah. Let's make him info. Let's see how much we have now. Yeah, still 1. I'm not able to generate a lot of response. So I need to write some code to, generate a lot of requests to this particular pod. And you will see that it auto scales automatically to more than 1 pod. So I think that's all I had. How would you integrate Kubernetes services with Kubernetes? Definitely, if you all want, I can have a subsequent webinar where I can go more details into it and show you step by step by doing coding actually as to I think that this thing works. So I think that's all I had. So if you have any more questions, feel free to ask me. Even if you don't have,
Hi,
you can ask me later.
hi Ritesh, this is Sandeep. I have one question regarding the Kubernetes. How licensing works in Kubernetes? Because we are pulling the images. Okay, so where we are putting the license fees and how licensing works?
So the way it works is from the cost perspective, there's no cost for Kubernetes. So each Kubernetes environment actually contains, go there. Each Kubernetes environment actually contains, the worker nodes and the master nodes, right? So there's no cost for the service. The only cost for the service is the virtual machines that you have created as part of this particular hosting of your pods. So there is a virtual machine scale set that gets created automatically. And this virtual machine scale set, you will see that there are 2 nodes, 2 virtual machines into it. So this is the cost you need to pay. So this instance that you see here, there are 2 of them. And when you say kubectl get nodes, these are the 2 instances you get. So this is the cost you need to pay, and it contains obviously an operating system. And if it contains an operating system which needs a license, either you bring your license, then the cost reduces around 40 to 50%. If you don't bring your own license, then you pay the cost of the VM, that's all. So there's no licensing as such, you are just paying for the cost of the virtual machine. That's how it works. If you're using an OS which does not have a license, like for example open source Ubuntu, then you don't have to pay anything for that. You just pay for the size of the VM. That is the whatever compute and memory you are using on that VM. That's what you pay for.
Got it. Thanks.
Yeah. So any other questions anybody has?
Ritesh, I have another question. See, actually, except VM, remaining things, everything is free, right?
Obviously, you're using some storage because the VM needs storage, so you're
Okay.
paying for storage as well. But AKS as a service is no charge.
Okay.
So is the application source code available? I can make it available, not a problem. What other ways we can use these services for free? I mean, you can use it for free in the sense as even if you create an Azure subscription, I think AKS they're providing for the first month free, so you can definitely use it free for the first month. Use it and learn with that. Hello all, we'll be having next session with Sudhir Rawat. Okay, that's awesome. Okay, I think there's any other questions. There's no other questions on the chat window, and if there is anything, let me know. So I hope everybody enjoyed it. There was something to take away that how you would host. There are many more things that's possible on this, but it's not possible for me to cover in 45 minutes. For example, the example that I showed you was using a Vision API. I can do a custom Vision API where I bring a lot of my own images. I train my own images and then host that particular application also within Kubernetes and Kubernetes services along with containers. I can do those things as well. And so, for example, if I go to Vision API, custom Vision API over here, not over here, give me a moment. So if I go to custom Vision, this is also provided by Microsoft. If I come here, I created a small project over here. So like cars, and there's something called, I added a lot of images for cars and trucks and how do you differentiate between them. So I exposed this entire thing as a Docker image and I put it as an image on my repo, which is nothing but the one that I was showing you earlier called my classifier. And then I can use that classifier directly now to see whether it's an image. So let me see where is that hosted. I can show you more immediately. So my classifier should have been it's over here running on this particular IP address. I can copy this IP address. Go back here. It's already here. So I give a body, for example, if I run this particular image, what is this image? This image is this is a car, right? And if I send this image to that particular server, it tells me that the probability is 99% that it's a car and the probability is 0.1% that it's a truck. So I can do all of these things. Now it's running on Kubernetes. I can scale up, scale down, and things like that on Kubernetes. So it's a great tool to host your cognitive services application, intelligent applications. Okay, so I think I'm on across my time. So thank you very much, guys.
Thank you, Ritesh, for your time. I know you are traveling today and still you make out this time early morning for us. Thank you very much for sharing this informative session.
Yeah, just a
Thank you,
quick
everyone.
question, Ritesh. Before to that, any percentage of accuracy, we can expect for invoice processing. That's all printed format.
Yeah. So see, at the end of the day, when you look at let me show you. When you are looking at the performance, a few things like precision, recall, sensitivity, relativity, and things like that. You see over here, 100%. You need to. It's 100% is good, but 100% not be good as well, depending on the business context. So you need to make sure what business context you are at. Always make sure recall is very high. Precision is high or not doesn't matter, but recall has to be high. Recall is basically says, for example, out of whatever you did, whatever information you send, out of that, how many were correct? So, for example, if there are 100 cancer patients and recall says 95, is it good or not? It's not good. Why? For 100 patients which have cancer, 95 you diagnosed them with cancer, but 5 you didn't diagnose with cancer. So that is not a good result. For such scenario, 100% is needed. Whereas there might be scenarios where 95% is good. So obviously you need to have something beyond 95. For example, in classification cases, these are all cases of classification. And depending on the business context, you might want 100%. So I would leave that with you to decide what is good for your business case. Thanks, Kasem. I think it was great talking to you.
Yes. Yes,
And feel
Ritesh.
free to organize more sessions if you want.
Soon. Thank you, Ritesh. Thank you, everyone. Bye bye.
Thank you much, everyone.
Thanks. Bye.